Closed-level gauging. Closed-level gauging ensures that no cargo liquid or vapor is released to the atmosphere during level measurement. Common closed-level gauging devices fitted on board an LNG carrier are float gauges, capacitance gauges, radar gauges, nitrogen bubbler gauges, and ultrasonic gauges. The purpose of any level gauging system is to provide the cargo operator an accurate level reading, especially during topping off, completion of loading, and finishing off completion of discharge cargo. These systems are also linked to various level alarms, giving audible and visual warning signals in the centralized control room. Two of these alarms are for emergency purposes and automatically shut down the particular tank valve at 98.6% tank level and the manifold valves at 99% tank level respectively. The float gauge installed in a tubular well consists of a float attached by a tape to an indicating device which can be arranged for local and remote readout. Alternatively, guide wires may be fitted. Float gauges have gate valves for isolation so that the float can be serviced in a safe atmosphere. The float must be lifted from the liquid level when not in use. If left down, liquid sloshing while at sea will damage the tape tensioning device. Float gauges cannot normally register a liquid level of less than 10 centimeters from the tank bottom. The float gauge, the graphic shows the level measurement systems installed in a membrane-type LNG carrier. The WESO float gauge is used if the capacitance-type level gauges fail, if permitted by the terminal representatives. The accuracy of the float gauge measurement is the same as the capacitance gauges. Nitrogen bubbler gauges measure the pressure necessary to displace liquid cargo from a small bore tube mounted vertically in a tank. A sufficient pressure of nitrogen is introduced into the tube to displace the liquid and to commence bubbling at the bottom. The pressure necessary to do this is measured and is a function of the liquid level and the liquid density. For cargoes of known density, the level readout is obtained directly. By installing two such tubes, one alongside the other and with their lower extremities a known vertical distance apart, the density of the cargo can also be determined. Electrical capacitance level gauge. Capacitance gauges measure the change in electrical capacitance. The liquid level is determined by measuring the electrical capacitance of the sensor segment intersecting the liquid level. The capacitance of this segment is compared with the capacitance of a reference segment located below the liquid surface. The ratio of these two measurements results in the accurate determination of liquid level, which is independent of liquid properties such as dielectric constant, temperature, and density. The probes are enclosed within a protective tube, which extends throughout the depth of the tank and provides a continuous indication of liquid content at all levels. The devices having no moving parts are usually reliable, but must be kept free of dirt, rust, water, and ice, as they can cause inaccuracy. Ultrasonic gauges operate on a similar principle to echo sounders. They measure either the ullage or the liquid depth by reflecting sound waves from the liquid surface. The transceiver may be mounted either in the tank dome or at the tank bottom, depending on whether the ullage depth or liquid dip is to be measured. On gas carriers, these gauges can be unreliable. There can be problems in obtaining satisfactory readings when loading tanks by the spray line. Other points of inaccuracy can develop as cargoes of different types are loaded. Furthermore, readings can vary depending on temperature and pressure changes. These gauges operate on the principle of radar. Such equipment works at very high frequencies, approximately 11 GHz. Radar-type liquid level gauges have now been specially developed for liquefied gases and their usage on gas tankers. The equipment provides measurements adequate to meet industry requirements. Radar-type liquid level gauges have now been specially developed for liquefied gases and their usage on gas tankers. The equipment provides measurements adequate to meet industry requirements.